In this series, we've been looking at the general linear model, and we're going through all of the designs that we have covered so far in this course and looking at what the model looks like for each of those designs. It's now time to turn our attention to a mixed design. Why mixed? Because we're going to have both a between subjects factor and within subjects factors. Subjects are randomized to J experimental conditions and measured K times or matched into blocks and randomized to a second experimental condition. So if you look at that first sentence about the mixed design, you should get the sense that it's a combination of having a between subjects factor design, like the one factor design we looked at, but adding a second factor that is repeated measures or a block. And that's in fact what it is. So you have two factors. One is within the repeated measures or block, and then the other factor is a between subjects factor. And then, of course, because you have two factors that you actually can analyze, you have an interaction, and the interaction is also within subjects. When you interact a uncorrelated factor with a correlated one, you end up with some correlation. Each score is the sum of the mean, the condition effect, the effect of time, the interaction between conditions and time, and the residual that is unaccounted for by the experimental factors. So here we have a score or an observation Y for person J, or person I rather, in level J and level K. So little j, the jth level of the capital J factor, little k, the kth level of the capital K factor. We have that person I in there, and that score is seen as a sum of the baseline effect, that is the mean, plus the effect of being in the between subjects factor, alpha, plus the residual for the between subjects factor, plus the effect of being on the within subjects factor, either time or a block, being within that block. And that's going to be beta at the kth level, plus the interaction of alpha beta at the jth and kth levels, plus the epsilon or the error for the within subject. So here we have two errors. And in essence, we're going to have two ANOVA tables. An ANOVA table for the first part, alpha and epsilon b, and then an ANOVA table for the second part, beta, the interaction, and epsilon w. Let's take a look at an example that we've looked at in a previous video. This was from a study of the effectiveness of Rogaine as a drug for increasing hair growth in women with androgenetic alopecia. So we're looking to improve hair growth in these women, and note how this was done. First of all, the women were assigned to either a control, you can see the control with the yellow box plots here, or a treatment, you can see that with the green box plots here. Those were assigned at random, and the individuals in the control were only in the control throughout the study, and those in the treatment only in the treatment throughout the study, so that's a between subjects factor. On the other hand, everyone in the control group was measured at 0, 8, 16, 24, and 32 weeks, and so that's a within subjects factor. Similarly, everyone in the treatment group, 0, 8, 16, 24, and 32 weeks. So time became a within subjects factor. So when you end up doing your analysis of variance down here, you have the between subjects factor in a separate ANOVA table where we're looking at the difference between being in the control or treatment. At first blush, you may say, I want to look at the difference between control and treatment. But what you're actually interested in is looking at the difference in hair growth between the control and treatment, and that's the interaction of the condition with time. So that's the main effect that's of interest here. And we can actually see that back up here in our line graph. We're wanting to know if that solid line outperforms the dotted line, the solid line being the Rogaine group, the dotted line being the control group. So we're focused only really on the interaction in this study. Now, I have said that when you have negligible or no interaction, you can go to main effects. And while that is theoretically true, it's practically unimportant in this case. Why? Because if I was to go to look at control versus treatment, the between subjects factor as a main effect, because I found little interaction, that would only be telling me how the treatment performed to the control when you average all the times together. And what doesn't make sense about that to me is we have 0. We have before there was even any Rogaine administered. So it would be like comparing a control to a control and then adding in some Rogaine to one of the groups and comparing that to the control. It doesn't make a lot of sense. Similarly, if we look at time as a main effect, you're combining Rogaine and control and then looking at the effect of time. Again, that doesn't make a lot of sense to me, especially if what we're wanting to look at is the effect of Rogaine. If Rogaine was not effective and you had parallel lines here, this would just become a study of natural hair growth. And that's not what this is about. And so I'm only going to focus on this interaction effect. Because it's the interaction of a between and within subject factor, that makes it a within subject factor, so therefore we need to look at sphericity. And that's what we're looking at here, looking at sphericity, homogeneity of variance of all the differences between the pairs of weeks. And then we look with the QQ plot at normality. And again, independence here is independence of the individuals in the between subject factor, that is between the control and treatment. Independence is not needed for individuals across the weeks because we purposefully are measuring the same individuals across weeks. So looking back at our model, we have alpha in this case would be whether they were in the Rogaine group or not Rogaine group. Beta would be the weeks. Alpha beta would be the interaction of the treatment condition, Rogaine or no Rogaine, with weeks, and that's what's primarily of interest. And then, as you saw, we had separate residuals, one for the between subject factor, one for the within subject factor, but that within subject factor is really the only one that we're going to use here. So that's the mixed design and corresponding model. I believe we only have one more design that we've covered in all the videos in this course, and that's the randomized design with a covariate. So I'll see you in the next video so we can learn about the model to use with that design.